Okay, so this lesson is use geometric sequences, and the key concept for the nth term of a geometric sequence is an is equal to a1 times r, which is the ratio to the power of n minus 1. So we're going to look at a real world example. So our real world example from our book. So this says music. So this is a music. It says if the pattern continues, how many emails will be sent on the 8th round? So we're going to say pattern continues, how many emails will be sent on the 8th round. So what we need to know is that 5 emails are sent in the first round. So in the second round, each of those 5 emails, the people who receive them, the recipients, also send 5 emails. And this continues up until the 8th round. So we have a geometric sequence. So it's a geometric sequence, and we need to say what the ratio. So the common ratio, because everyone is going to be sending 5 emails, the ratio, which is R, is 5. So we're going to use the formula now to solve. So to solve the formula, an is a1, and this is the ratio to the power of n minus 1. And we're going to substitute in what we know. So we said the term will be 8, because it's 8 emails. A1, the first number, is 5, because this is the first number of emails sent. The ratio we said is 5, so this is multiplied by 5. N, so n is 8, because we're talking about the 8th term. So that's 8 to the minus 1. So the value for 8a is going to be 5 times 5, and 5 is to the power of 7. And if we work this out, this is 78,125, which is 5 to the power 7, and multiply that by 5, and we'll have 390,625 emails sent on the 8th round. Now we can check this. So we're just going to do a check. So to check this is correct, the first 8 terms, we can write out the first 8 terms, write out the first 8 terms in our sequence. Now we know it's 5, and each 5 is going to be multiplied by 5. So the ratio is times 5. So the next term would be 25, and if we times that by 5, we will have 125, and we multiply that by 5, which would be 625. And again, if we multiply that by 5, that will have 3125. And if we multiply this by 5, we'll have 15,625. And this by 5, this will give us the next value of 78,125. And finally, 1, 2, 3, 4, 5, 6, 7. The 8th, if we multiply this, the 8th term will be 390,625, which is what we had there. Okay, so we have a guided practice question, and this is about emails. So Samaya, she receives a joke in an email that asks her to forward it to 4 of her friends. She forwards it to each of her 4 friends, who will forward it to their 4 friends, and the pattern continues. So if the pattern does continue, how many people will receive the email in the 9th round? So if we put the formula, So a to the n is a1, and that's r to the n minus 1. So an, there's going to be 9 terms because it's the 9th round. The first number is going to be 4 because it's 4 emails. And the ratio is to each 4 friends, so that is going to be 4. So we just substitute in the values. So an is 9, and so let's write a9. So a9. a1 is 4. The ratio is 4 and is to the power of 9 minus 1. So a9, this is going to be 4 to the power of 8 is going to be 65,536. And if we multiply this by 4, 262,144. And just to check, so we're going to check if we were to write everything and we multiply by 4, so 4 times 4 is 16, and we multiply by 4, this is 64, multiply by 4, and 64 times 4 is 256, so we multiply that by 4, 1024, multiply this by 4, 4096, multiply this by 4, 16384, and multiply this by 4, 65536, and finally multiply this by 4, and we have 262,144, which is our value. Okay, so example 2, we're asked to write an equation for the nth term for a geometric sequence, and we're given 0.5, 2, 8, 32. So the first thing we need to do is find the ratio. So to find the ratio, we're just going to divide. So we could choose any of these terms and we will have the same answer. So we know the ratio. So I'm going to write here, ratio is 4. And the next thing we need to do, so A1 is 0.5. And we need a to the n. So we don't know that yet because the term continues. So we're going to use the formula an is a1 multiplied by the ratio to the power of n minus 1 and substitute in the values. So a to the n, so a1, this is 0.5, the ratio is 4, and it's going to be n minus 1. So this is our final formula. So let's have a look at example 2. So B, we're given A4 is 5 and R is 6. So we need to find, first thing we need to do is find A1. So we're going to use the formula. A1 is R to the n minus 1 and use the information we know. So we're given that A4 is 5. So this is A4. And A4, the ratio is 6. And the term would be okay, so this is going to be to 4 minus 1 because there's 4 terms. Now I'm going to substitute in the values. So A4 we know is equal to 5. A1 we're trying to find. And we have 6 to the power of 3. So if I work this out, this is going to be 216. So now we need to divide both sides by 216. And that will simplify. So A1 is going to be 5 over 216. Now I'm going to use this now in my equation. So next thing I'm going to do is write my equation. So write the equation. And so we know that a to the n, a1 r n minus 1. And we're going to change a to the 1 to 5 over 216. The ratio is 6 and n minus 1. So this is our formula. So guided practice, 2 questions, 2A and 2B. So pause and have a go and press play. So 2A, if you look at 2A first, and we have 0.25, 2 minus 16, 128. We need to find the ratio. So to find the ratio, we take the terms and we divide. So I'm just going to take 2 of the terms. So minus 16 divided by 2 is minus 8, and 2, this is going to be the same. So the ratio is minus 8. So I'm going to put this into the formula. So also we know A1 is minus 0.25. A to the n, we don't know the last term. So using the formula, an is a1 r to the n minus 1. An, so the first term is minus 0.25. The ratio is minus 8, and this is to the power of n minus 1. And we just need to write this as a final answer. 125 minus 8 and n minus 1. So that is the formula. And 2b. So 2b, we have, we're given A3 is 16 and R is 4. So we just need to do a little bit more. So AN, A1, we need to find the first term. We don't know that yet. So we're going to substitute in what we know. So we know A3 is A1. The ratio we're given is 4. So we're just going to substitute in. The terms, we're using 3. So this is going to be 3 minus 1. And we can substitute in the value. We're given A3 is 16. So 16, A1, 4 to the power of 2. This is going to be 16. So 16 divided by 16 is A1. So A1 is going to be 1. So our formula, if we substitute this in, so we got AN is 1 times 4, n to the minus 1. And we can just write 4 to the n minus 1 as our final formula.